7th grade, Chapter 9, Section 7, Independent and Dependent Events. So what are those? Well, an independent event is where one event does not affect the other event. For instance, if you have a bag of marbles and you pull out a random marble and then you put it back in, it does not affect the next choice. Whereas a dependent event is when the outcome of one event affects the outcome of another. So in other words, if you had 10 marbles, the probability of getting a certain marble, say they're all different colors, every single one's a different color, you would take one marble out. Well, the probability of getting that one marble is 1 out of 10. But say I don't put that marble back. I keep that marble and I put it in my pocket. And now I want to pull out of this bag again. Well, now the bag is different. It only has 9 marbles in it. So now my probability of getting a certain color is I put my hand in, and now it's 1 out of 9. So it's a dependent event. The first event affected the second event. But we can't forget what we've already done, permutations. So how many permutations are possible of the letters in the word secret? Well, how many letters are there? There are 6 when you count them up. And how do we find those permutations again? We can say we have 6 spots, 1 for each letter. Well, how many choices are there for the first letter? Well, there's 6 because there's 6 letters in secret. Well, now we've used 1. So how many are left to choose from? 5. And now we've taken out 2, so that leaves 4. We've taken out 3. And then when we multiply this, we get 720 different ways of arranging the word secret. Let's see, Julie, Dan, Janet, Kevin, and Michael are all entering a contest. 2 names are pulled out of the hat at one time, so only 2 spots. In how many ways can the contest winners be selected? So there's 1, 2, 3, 4, 5. 5 times 4, 20 different ways. A child has the magnetic letters VOLE. In how many ways can the letters be arranged? This is just like the first one. 4 times 3 times 2 times 1 is 24 different ways. Carlos, Serena, and Nicole go to the movies and sit in a row of 3 seats. How many seating arrangements are possible? So 3. There are 3 of them. So we get 6 possible ways. And how many ways can a football coach arrange the first 5 players in a lineup of 11? So first 5 of 11. So 11 times 10 times 9 times 8 times 7. And that is 11 times 10 times 9 times 8 times 7. We get 55,440 different ways to arrange the first 5 players. So what are we doing today? How can you predict the outcome of future events? Well, we're going to learn to do it today by finding the probability of independent events and the probability of dependent events. And of course, I already talked about what independent and dependent are. One, independent, they don't affect each other. Dependent means that they have to depend on each other. One can change the other. Probability of independent events. So the probability of 2 independent events can be found by multiplying the probability of the first event by the probability of the second event. So we're multiplying here again. One letter tile is selected and the spinner is spun. What is the probability that will both be a vowel? So we need to know what a vowel is. Well, your vowel is A-E-I-O-U. So we have, let's see, one letter tile is selected and the spinner is spun. So we have a probability of 2 out of 4. And we have a probability of 1 out of 3, which would be 2 out of 12 when we multiply, and we reduce down to 1/6. That's the multiplication way. You can see how they did it here with the tree diagram, which is all great. You can most certainly do it that way. You can also see how once you learn the multiplication, how much quicker it is. I do suggest going ahead and learning how the multiplication works. So again, you can go through and say the options of the tree and do them all out, just like we did in other sections. And you can see we had this, probability that both would be a vowel, so we can't have a G in there, can't have a B. E, A, let's see, AA, and there you go. That's 2 possible out of 12, or 1 6 when you reduce it down. 2 spinners below are spun. What is the probability that both spinners will show a number greater than 6? So numbers that are greater than 6. Let's see if it'll let me. That didn't work. Now we can read this. So again, numbers greater than 6. So 7, 8, 9, greater than 6. 7, 8, 9. So we have 3 out of 1, 2, 10. And 3 out of 10 gives us 9 out of 100 when we multiply those two. So we have 9 out of 100 chance, or a 9% chance of getting a number greater than 6. The spinner and number cube shown are used in a game. So a dice, right there. What is the probability of a player not spinning blue and then rolling a 3 or 4? So not blue. That means you have 1, 2, 3, 4. So 4 out of 5 for probability of not blue times the probability of 3 or 4. Well, 3 or 4 there, that's 2 numbers out of 6, which can be reduced to 1/3 times 4/5. So 4/15. So we have a 4 and 15th probability of getting not blue and then a 3 or 4. A red number cube and a white number cube are rolled. The faces of both cubes are numbered from 1 to 6. What is the probability of not rolling a 3 on the red? So the red, white. So the probability of not 3 on the red cube and rolling the number 3 or less, probability 3 or less on the white number cube. So again, we're going to be multiplying these. So the probability of not 3, well, there's 5 out of 6 other numbers. And then the probability of 3 or less, that's 3, 2, and 1. So that's 3 numbers out of 6, which reduces to 1/2. So we get 5, 6 times 1/2 gives us 5/12. So we have a 5 in 12 chance of rolling a not 3 on the red cube and a 3 or less on the white cube. If 2 events, A and B, are dependent, so now they affect each other, then the probability of both events occurring is the product of the probability of A and the probability of B after A. So now we have to decide if things are going to affect each other. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that the 2 apples are chosen. Well, let's start with our first choice. So we have 1 choice. We have 2 choices, and we know we're going to multiply them. So Ignacio goes first. The chances of him getting an apple are 5 out of total. So that's 11 and 5, 16. So 5 out of 16. Now, he has taken an apple out. There's no longer that apple there. Now there's 4 apples in there. So that leaves us with the chance on the second selection for Terrence. He has the choice of 4 apples out of not 16, but 15, because we took 1 apple out. I'm going to cross reduce here, just to make my life a little easier. So now I get 1 times 1 is 1. 4 times 3 is 12. And I get a 1 in 12 chance of both choices being apples. There are 4 red, 8 yellow, and 6 blue socks mixed up in a drawer. Once a sock is selected, it is not replaced. Find the probability of reaching into the drawer without looking and choosing 2 blue socks. One thing, if they tell you not replace, they mean it needs to be dependent event, so you can automatically say that the numbers are going to be different. So there are 4 red, 8 yellow, and 6 blue socks. We want 2 blue socks. So the chances of getting blue the first time are 6 out of, let's see, that's 10, so that's 8, 18. Now we've taken away 1 blue sock. I have 5 left over. So now the chance of it being a blue sock again is 5 out of, not 18, but out of 17. We can't cross reduce, but we can reduce up and down. So 6 goes into 6 once and into 18 3 times. 5 times 1 is 5. 3 times 17. 3 times 17 is 51. So there's a 5 in 51 chance, or 5 out of 51, that we will get 2 blue socks as we choose. So today we need to define the probability of independent events, like rolling a number cube and randomly selecting a marble, and find the probability of dependent events, like randomly selecting 2 marbles without replacing the first one. So explain how to determine the probability of 2 independent events occurring.